Hello everyone, welcome back to the Atharva Gate Academy. Myself Chinmay Thaduk. Now today in this video, we are going to start new topic, that is thermal stress and strain. We know that when we change the temperature of any structural body, then dimension of that structural body changes according to the temperature. If we increase the temperature of structural body, then dimension of structural body increases. And if we decrease the temperature of structural body, then dimension of structural body decreases, right? So due to change in temperature, there is change in dimension of structural body, and due to that stress and strain is produced in the body, and that stress is called as thermal stress and that strain is called as thermal strain. Let's say we have any body having cross section area A, which is constant throughout the length, and length of this body is L. Now let's say we change the temperature of this body as delta T. Let's say we increase the temperature of this body as delta T. So here area of this body is going to be increased and length of this body is going to be increased. Let's say right now we only focus on the length of this body. So let's say change in length of this body is delta L. From the experiment, it shows that change in length is proportional to the original length of this body, means delta L is proportional to L, and delta L is also proportional to delta T, that is change in temperature. So if initial length of the body is more, then change in length of body will be more, and if change in temperature of body is more, then change in length of body will be more. So we can write that delta L is proportional to L into delta T. And if we want to remove this proportionality sign, then we have to put proportionality constant. So it will be delta L is equal to alpha L into delta T. And here this alpha is proportionality constant. Here this is proportionality sign and this is alpha. Okay? And here this alpha is called as coefficient of thermal expansion, and which is the property of body. Now what will be the unit of alpha? Let's say here alpha will be equal to delta L divided by L into delta T. Unit of delta L will be meter, unit of length will be meter, and unit of delta T will be Kelvin, or it will be in degree Celsius. So we can write that unit of alpha is Kelvin inverse or degree Celsius inverse, right? Now here this equation is important. Now let us rearrange this equation. Here let's say this is delta L and we take this L left side of this equal sign. So it will be delta L divided by L, and it will be alpha into delta T, right? And we know that delta L divided by L, that is change in length divided by initial length, is equal to strain in the body. So we can write that strain is equal to alpha delta T, and this strain is called as thermal strain in this body. Now we also know that sigma is equal to E into epsilon, right? This stress is equal to Young modulus into strain, and here we know the value of strain, that is alpha delta T. So we will put this strain here and we will get sigma is equal to E alpha delta T. So this is going to be the value of stress in this body, and that is called as thermal stress, right? Now we have three equations in this topic, that is equation of delta L, equation of strain, and equation of stress. Now you have to remember one thing, that stress will be produced only if there is restriction to strain. By saying restriction to strain, I mean that restriction to change in length, or we can say change in dimension, right? So if we restrict the change in dimension of this body, Means if we fix this surface of body and this surface of body, means actually we are restricting the change in length of this body, because now there cannot be change in length of this body. Understand carefully that stress will be produced only if there is restriction to strain. If there is no restriction to strain, there is no stress. Here we are restricted the length of this body, so there will be stress in this body, and value of that stress will be sigma is equal to E alpha delta T, right? And if we are not going to restrict this body, means if we remove any fixed end of this body, let's say this end, then there is no any restriction to change in length of this body. Means this body is free to elongate in this direction. Means change in length of this body is allowed. So this will be the case of free expansion. Because here this body can expand in this direction, right? And in that case value of stress will be 0, because there is no restriction to strain. So value of stress is 0, means there is no stress. So in this case value of stress is 0. I hope that you understand this concept, right? If we restrict the change in length of this body, then stress will be produced and value of stress will be E alpha delta T, and if there is no restriction to change in length of body, then this case is called as free expansion, and in that case value of stress will be 0. What is free expansion? When there is no restriction in change in dimension due to temperature difference of body, it is called as free expansion, right? That we have discussed earlier. Let's say we have one body here, and this is the length of the body, this is width of the body, and this is height of body. Here we are taking this axis as x-axis, this axis as y-axis, and this axis as z-axis. Now if we increase temperature of this body as delta T, then what will be the value of change in dimension of this body, and what will be the value of strain in this body? Due to this temperature difference, change in length of this body, let's say it is delta L, it will be L alpha delta T, right? Here L is initial length, alpha is coefficient of thermal expansion, and delta T is change in temperature. Similarly, what will be change in width? It will be B alpha delta T. Here this B is initial width of this body. And what will be the value of change in height? It will be H alpha delta T, right? Now we know that strain is alpha delta T. Here there is no any term of dimension in this strain. So value of strain in x direction will be alpha delta T. Similarly, value of strain in y direction will be alpha delta T, and value of strain in z direction will be alpha delta T. Here we can also find out this from here. If we take delta L divided by L, then we will get strain in x direction, that is alpha delta T. And similarly, delta B by B will be alpha delta T, that is strain in y direction, and delta H by H will be alpha delta T, and it will be epsilon Z, that is strain in z direction. We can also say that this delta L is deformation due to temperature in x direction, right? This delta B is deformation due to temperature in z direction, and this delta H is deformation due to temperature in y direction. And here we can also write that this epsilon x is epsilon T, that is thermal strain in x direction, this is thermal strain in y direction, and this is thermal strain in z direction. Actually there is mistake. This B dimension is in Z direction. So here I have to write Z. And here I have to write Y because this height is in Y direction. So here I have to write epsilon Z and here I have to write epsilon Y. Right? Next, we are going to discuss some examples in which we will find value of thermal stress and value of thermal strain. Fine? Here, this is the first case in which we have this cylindrical body restricted on both the sides. Means this is the case of completely restricted cylindrical body. Here the length of this cylindrical body is L and diameter of this cylindrical body is D. This cylindrical body is fixed at both the end, this end and this end. Fine? Now if we increase temperature of this cylindrical body delta T, then what will be the value of thermal strain and thermal stress in this body? We have already derived the equation to find out thermal stress and strain in this case, right? Thermal strain is alpha delta T and thermal stress is E alpha delta T, right? This is thermal strain epsilon T and this is thermal stress sigma T. In this example, we are going to find these values by using different approach. Fine? Let's say first of all we have body fixed only at one end. Means at this time, let's say this body is not restricted at this surface. Means we remove this fixed end from this surface. Fine? Now here we know that if we increase delta T temperature, then length of this body will increase. But here it is not allowed because we fixed both the surface of this body. So first of all we are going to consider that we allow to deform this body beyond this surface. Means due to this temperature difference, this body is allowed to deform like this. And once it is deformed, we are going to apply one force in this direction and then due to this compressive load, we will contract this body up to this surface. Here you can understand that due to increase in temperature delta T, this body will elongate like this, right? And then we will apply load at this surface in this direction like this. And let's say this force is reaction R. This R will be the reaction due to this fixed surface, right? And by applying this reaction, we are going to contract this body up to this surface. So due to this reaction R, this body is going to be contract like this. And here it will be in its original position, right? So what we have done till now? First of all, we remove this reaction and we increase the delta T temperature. So this body elongates up to this point. Let's say here this deformation is delta T. Means it is deformation in body due to delta T temperature difference. Now we are going to apply this compressive load R. So again deformation by this load R will be this, right? And let's say this deformation is delta R. And from the figure you can see that value of delta T and value of delta R is same, right? Delta T is equal to delta R. Here we are only taking magnitude of this deformation. We are not considering direction of this deformation, right? Now we know that what is the value of delta T. Delta T is the deformation in body due to temperature difference delta T. So it will be L alpha delta T. Here L is initial length, alpha is coefficient of thermal expansion and delta T is change in temperature. Now what will be the value of delta R? Delta R will be deformation due to this reaction R. Means we can say that this deformation R or this delta R is deformation in body due to axial load R, and we know that value of deformation due to axial load delta R will be RL divided by AE, right? It is similar as PL by AE. Here value of load is R. Actually this R is compressive load, right? So we have to take it negative, but we are only considering magnitude in this example. So we will take this R as positive. So from here we can write that delta T, that is L alpha delta T, which is equal to delta R, that is RL by AE. Here this LL will be cancelled out, and we can find out value of R, that is value of reaction. So value of R will be equal to AE alpha delta T. So if it is asked to find value of reaction at the end, we can find out by this method. Now you can also find value of stress, that is R divided by A, right? Load divided by area. So it will be E alpha delta T. So it is same as discussed earlier, right? Now here you have to understand that this stress will be compressive stress, because here this reaction will try to compress this body. So you have to take value of stress as negative. I hope that you understand this concept, because we are going to use this concept in next examples. Okay? Now let's say in this example, if it is asked to find out change in diameter of this body, then how can we find out? We have to find out value of change in diameter due to change in temperature delta T, right? So we will use same approach as discussed earlier. First of all, we are going to remove this restriction from this end, means it will be case like this, and then we will increase delta T temperature of this body. Due to increase in temperature delta T, dimension of this body is going to be increased. Let's say length of this body increases like this, and diameter will also increase due to this temperature difference delta T. So it will be something like this, right? And let us consider that this direction is X direction and this direction as Y direction. Now we know that if we increase delta T temperature of this body, then value of strain in both the direction X and Y will be alpha delta T, right? It will be equal to epsilon T in X direction is equal to epsilon T in Y direction, correct? Here strain in Y direction is important for us, because if we have value of strain in Y direction, then we can find out delta D, because strain in Y direction is equal to delta D divided by D. It is change in diameter divided by initial diameter D, right? Now understand that here we have restriction, right? So there will be reaction at this end. So now we are going to apply reaction at this surface in this direction. Let's say it is R. So there will be contraction in body, right? Means the length of this body is going to be decreased, and it will come to its initial position, this, right? And understand that if length is going to be increased of this body, then diameter of this body will increase like this, right? So due to this reaction, there is strain in X direction and there is also strain in Y direction, and that strain in Y direction due to this reaction will be this much, right? And here this will be the value of strain due to this reaction R in X direction, right? Now let's say here this value of strain is epsilon X and it is due to this reaction R, so we will say that it is epsilon X R. Now what will be the value of epsilon X R? Now understand that this value of strain will be equal to strain in body due to temperature difference delta T, that is this. So this will have same value as alpha delta T, but this strain will be negative because we are applying compressive load R and here length of the body is decreasing, right? So it will be minus alpha delta T. Fine. We also know the formula of Poisson's ratio mu, that is minus lateral strain, that is in y direction, and linear strain, that is in x direction, right? Here our linear direction will be this direction because we are applying load in this direction, right? Now at this time, let's say this epsilon x is epsilon x r and this epsilon y is epsilon y r. So from here we can find out epsilon y r. Epsilon y r will be equal to minus mu into epsilon x into r. And we know the value of epsilon x r. It is minus alpha delta T. So we will have value of epsilon y r equal to mu alpha delta T. Fine. Now understand that this strain is strain due to temperature difference delta T in this body in y direction, that is epsilon T y, and it is having value alpha delta T. And this strain is strain in y direction due to this reaction R applied on this body, and this strain is epsilon y r and it is having value mu alpha delta T. Let's say total strain in y direction is epsilon y. It will be epsilon T y plus epsilon y r. So it will be equal to alpha delta T plus mu alpha delta T. And here we can take alpha delta T as common. So it will be alpha delta T into bracket 1 plus mu. Fine. So this is the value of strain in y direction epsilon y. Now we know that strain in y direction can be also written as delta D divided by D. So we can write that alpha delta T into 1 plus mu is equal to delta D divided by D. So from here we can write that delta D is equal to d alpha delta T into bracket 1 plus mu. Fine. So finally this is the value of delta D, means change in diameter of this body due to temperature difference delta T. I hope that you understand how to find value of change in diameter in completely restricted cylindrical body due to temperature difference delta T, right? Now we are going to discuss next example in which we have partially restricted body. Here you can see that we have this prismatic bar having length L and which is fixed at left hand side, and at right hand side there is small gap between this surface and this restriction, and distance between this surface and this restriction is lambda. Now we are going to increase temperature of this body delta T, and let's say we have to find out value of stress produced in this body. Right now we can consider two cases. In first case, if we increase temperature delta T of this body, then length of this body will increase up to this point, or length is increasing less than this value of lambda, means this surface is not going to exceed this restriction, right? And in second case, we are going to consider that this length of this body is increasing beyond this restriction, means if there is no restriction, then length of this body will increase more than this value of lambda, right? In first case, we will consider that due to this change in temperature delta T, length of this body will increase beyond this restriction, which is at distance of lambda from this surface. So here this change in length will be delta T because it is change in length due to change in temperature delta T. Here other dimension of this body is also going to be increased, but we are only going to focus on length, right? Now we know that there is restriction in this body. So what we will do, we will apply compressive load in this direction at this surface. Let's say this is reaction R, and this R will be the reaction by this restriction. Now we are going to apply this compressive load R, and due to this reaction this body will contract up to this restriction here, right? And let's say here this deformation, which is due to this reaction R, is delta R, right? Now understand that change in length from this point to this point is delta T, and it will be equal to sum of change in length from this point to this point plus this point to this point, means it will be equal to lambda plus delta R. So we can write that it is lambda plus delta R. Fine. Now we know that delta T is change in length due to temperature difference delta T. So it will be L alpha delta T, and here this L is initial length of this body, alpha is coefficient of thermal expansion, and it will be equal to lambda plus what will be the value of delta R. We know that delta R is deformation of this body due to axial load R, or we can say axial reaction R. So it will be RL by AE. Fine. And understand that this reaction R is compressive load here. So you should take this R as negative value, right? But right now I am going to keep it as positive. And at the end, whatever be the value of R, let's say at the end value of R comes out as 50 Newton, then we will take this 50 Newton as negative, right? Now using this equation we can find out value of reaction, and other values will be given to you. And if it is asked to find value of stress, that is sigma, then you have to directly find value of R divided by A, and here you can write R divided by A as sigma. So from here you can also find out value of sigma in this body. So I hope that you understand how to find out value of stress in partially restricted body. Fine. Now let us take this second case, in which if we increase delta T temperature, then length of this body is going to be increased, let's say up to here, means it is not going to exceed this restriction, right? So here we can write that change in length delta L, or we can also say that delta T will be less than or equal to lambda for this case. And if it is so, then we can say that this case is case of free expansion, because there is no restriction at this end, and change in length in this body is less than this lambda. And we know that if there is no restriction to change in length, then value of stress sigma is 0, right? That we have discussed in the case of free expansion. So in this case value of stress will be 0, means thermal stress will be 0 in this body. So I hope that you understand how to apply this type of concept in different types of body. Fine. Now today in this video we are going to stop here, and we will continue in the next video. Till then, stay motivated and happy practicing.